increasing. Increasing means intervals where the y value increases as the x values increase. Another way of visually thinking about that is that the graph is going to be going upward from left to right. So as x increases from left to right, the y values are increasing, they're going up. Okay, I'm going to change the color of this. Because I like colors. There we go. Okay, let's look at our sample right here. And let's look at intervals where the graph is increasing. Now, when we answer questions like this, we're just going to give the x intervals. So let me move this out of the way a little. Answer is just x intervals. You're not going to list the entire points. You're not going to list the y values. You're just going to list the x values. So looking at our graph, we've got a piece of the graph that's going upward from here to here, and we're just going to list the x values. So what x values, between what and what x is our graph increasing? Hopefully you're thinking through these in your head, or if you'd like, you can unmute, or you can type in an answer to get, just I'm trying to keep your brains engaged. It's a little bit harder with this distance platform. Okay, there's two other places where our graph is increasing. See if you can figure them out on your own, and then I'll write them down. So if you said right here from 3 to 4, you're right. And then there's another one right here from x equals 5 to x equals 6. So increasing. The graph is increasing from -4 to -2, from 3 to 4, and from 5 to 6. Let's go ahead and do decreasing, which is pretty much the opposite. So just to save me time, I'm going to paste what I just typed. And then I need to change some of the words. Intervals where the y values decrease as the x values increase. I can't spell. Thank you, spell check, for letting me know I spelled it wrong. And the graph slants downward. From left to right. So I'll let you take a second to write down whatever of that you want to. And meanwhile, when you're done with writing down whatever part of that you want to, look at the graph and see if you can find any intervals where this graph is decreasing. Yes, exactly. Just like with increasing. Yep. All right, I'm going to go ahead and write down the one that I see. I only see one decreasing, and that's from where x equals -2 to where x equals 3. So we just have that one interval from -2 to 3 where our graph is decreasing or slanting downward. Okay, what do you think constant means? It's going to be a flat horizontal line. The y value is going to stay the same. So I copied my text there again. Interval where the y values are constant as the x values increase. So the graph is going to be horizontal. Okay, so this particular graph has one little place where it's constant. From this point right here at 4, -6 to this point right here at 5, -6. Notice how the y value stays the same, -6, clear from here to here. So our answer is just the x values from 4 to 5. So with these three things, you're always just giving those x intervals to answer the questions. Okay. Next, local or relative maximum or maxima. Okay, so the reason I have words in parentheses is that some textbooks call these local maximum. Some of them call them relative maximum. And the reason I have maxima in parentheses is that's plural. Sometimes we have more than one local or relative maxima. So just kind of some explanation in wording. Okay, let's see. So local maxima are points with a larger y value than points on either side. So points are just locations in a graph, right? So if you have a location in the graph that has a larger y value than any other of the locations on each side of it, then that's a maximum value. Okay, so for example, on this problem, we definitely have a local maximum right here. So for this particular thing, we're actually going to list the whole entire point, because it's a point. It's where those points happen. So we have a local maximum at -2, 4.5. So that's actually our x and a y value for the point. Now there can be more than one. Do we see any other local maximums? If you're thinking and wondering if this endpoint here is a local maximum, it's not. Why is it not? And that's because if we look at our definition, points with a larger y value than points on either side of it. This one is like a hill in our graph. It goes up to the point, up to the peak, mountain peak, and then down the other side. This one goes up and stops. It doesn't have any points going down on the other side. So this endpoints are never going to be minimums or maximums. So you might want to make a little note that says never an endpoint. Okay, so local minimum is about the same thing here. I'm just going to grab this and copy it. So local minima are points with a smaller x value. So change larger to smaller, with a smaller y value than points on either side. So those are going to be low points in the graph, but not endpoints. Low points, not endpoints. My never looks really weird. Sorry about my handwriting there. Okay, so let's look at our graph. We have a low point here, but it's not a valley. Like it doesn't come down to it and then back up. It just is an endpoint, so we can't count that one. Then we have our local maxima here, and we have a minima there. Oh, is that going to be a local minimum right there? I believe it is. So we have a local minimum at 3, -8. And that's because the points on each side of it, the y values are bigger. It's like the smallest y value in that spot. Okay, what about the point 5, -6? Is that going to be a local minimum? If we look at a point here, that is bigger than the endpoint. But if we go to this side, those points are not bigger. They're the same. This is not a come down to it, hit bottom, and then go back up. So this one is not a minimum.